The alkaline earth metals are generally softer than most other metals, and they react readily with water, particularly when heated. Each has two valence electrons in its outermost electron shell. They are powerful reducing agents that readily give up electrons to other substances. The element beryllium can absorb large amounts of heat, which makes it useful for spacecraft and aircraft construction. Magnesium is a light metal. It is combined with other metals to make racing bicycles, airplanes, missiles, and other products that need to be lightweight and strong. Calcium is an essential element for countless living organisms. It forms the foundation for everything from shells to teeth and bones. Strontium goes into colorful flares and fireworks, and phosphorescent paints. A radioactive version of this element is one of the most deadly byproducts of nuclear fallout. Barium is a heavy silver metal that is used in spark plugs, vacuum tubes, and fluorescent lamps. And radium is an intensely radioactive element that doctors once often used to destroy cancer cells. In their pure forms, the alkaline earth metals are shiny silvery gray metals. They have relatively high melting and boiling points, and they are good conductors of heat and electricity. These metals have a gray-white luster when they are freshly cut, but they tarnish quickly when exposed to air. The heavier members of the group tarnish especially quickly. Beryllium, the lightest of the alkaline earth metals, is hard enough to scratch glass. But barium, the heaviest, is only slightly harder than lead. The alkaline earth metals react readily with water, especially when they are heated. They combine easily with other elements, and as a result, are never found in their pure, uncombined forms in nature. Although they are harder, stronger, and denser than the alkali metals, they are nearly as chemically reactive. The alkaline earth metals are so reactive because they are very electropositive. This means that, like the alkali metals, they easily lose electrons to other elements. Let's take a closer look at the periodic table. On the periodic table, the elements are listed in order of their atomic number. The atomic number represents the number of protons in an element's nucleus. In its normal or ground state, this nucleus is surrounded by an equal number of electrons. And as the atomic number increases, generally so does the size and mass of the atoms. As you read the periodic table from top to bottom, each horizontal line is called a period. Each period represents the number of electron shells the element's atoms normally have. For example, there are 4 electron shells in an atom of calcium, so it lies in period 4. Meanwhile, an atom of barium in period 6 has 6 electron shells. As you read across the table from left to right, the vertical lines of elements are called groups. Elements in a group have the same number of electrons in their outermost electron shells. These outermost electrons are called valence electrons, and they dictate how elements interact. Elements in the same group generally interact with other elements in similar ways. None of the elements greater than atomic number 83 are completely stable. All of these elements, including radium, are radioactive. All alkaline earth metals reside in group 2 because they each have 2 electrons in their outermost electron shell. Because atoms need 8 electrons in their valence shell to be stable, the 2 valence electrons in the alkaline earth metals makes them unstable. Nearly as unstable as the alkali metals, which only have 1 valence electron. As a result, the alkaline earth metals easily lose their 2 electrons during chemical reactions. And as you move from beryllium to radium, the atom's hold on their valence electron becomes weaker, making each alkaline earth metal more reactive than the one before it.